Welcome to Data Analytics Tools Series. I am Dr. Danielle Morin from Concordia University in Montreal, Canada. The topic of the lesson today is the binomial distribution. The binomial probability distribution has several properties, and it is a discrete probability distribution, so that means it takes only values that are integers. It is the results of a number n, fixed number of repeated identical and independent trials, and it has only two possible outcomes, success or failure, and the probability of success is constant from one trial to the other. Therefore, if x is a random variable following a binomial distribution with n trials and the probability of success is pi, we are interested in the probability of x successes in n independent trials. This probability is given by the following formula. F of x corresponds to the probability mass. It means the probability at one point. We write it as the random variable, taking the value small x, knowing the number of trials and the probability of success. This is the equation. The combination n choose x, pi, the probability of success to the power x, which is the number of success. 1 minus pi is the probability of failure. And the exponent is n minus x, which means the number of failure. So let us go into this formula in detail. Knowing my number of trials, the probability of success, and x is my random variable. We might be concerned about this entity here, n choose x. This is the number of combinations that we can do from a sample of n extracting x value. The formula is n factorial over x factorial n minus x factorial. Well, what is a factorial? A factorial is a multiplication of this integer n by the lower integer, n by n minus 1, n minus 2, all the way to 3, 2, and 1. For example, 3 factorial is 3 times 2 times 1, which gives me 6. 5 factorial is 5 times 4 times 3 times 2 times 1 is 120. 0 factorial is, by definition, equal to 1. Let us take an example. A university found that 20% of its students withdraw without completing the introductory course. Assume that 20 students registered for the course. Therefore, what is the probability that exactly 4 will withdraw? We recognize that it is a binomial distribution because the probability of success is the same for each student, which is equal to 0.2. N is the number of success, the number of objects that we will study. And x is the number of students who withdraw out of 20. If we use the binomial formula that we just saw, the probability that the random variable takes the value 4 is equal to 20 choose 4, 0.2 to the 4, 1 minus 0.2, which is the probability of not withdrawing, 0.8, to the 20 minus 4. Our portion here, 20 choose 4, we saw previously, this is 20 factorial over 4 factorial, 20 minus 4 factorial. Of course, when I deal with factorial, the number will increase very quickly. Therefore, it might be interesting, if I don't have access to Excel, to do it this way. If I expand what is 20 factorial, it's 20 by 19, 17, all the way to 1. 4 factorial is 4 by 3 by 2 by 1. and 16 factorial, 16 by 15 by 14, all the way to 3, 2, and 1. We notice that there are common terms at the numerator and denominator. They can be cancelled, and it gives me a much easier operations to perform, and this is 48, 45. Then I will plug this in my equation, times 0.2 to the 4, 0.8 to the 16, which is 0.2182. Of course, this can be done with Excel, and we will see that a little bit later. Another question would be, what is the probability that 2 or fewer will withdraw? What does it mean? 2 or fewer. That means it could be 0, it could be 1, or it could be 2. Therefore, I'm looking at the probability that x is equal to 0, plus the probability that x is equal to 1, plus the probability that x is equal to 2. Then when I substitute in the previous equation, I will obtain a sum of probabilities, which is 0.2060. Another question we could be asked is, what is the probability that more than 3 students will withdraw? The important is to know more than 3, not 3, but more. More than 3, so that would mean maybe 4, 5, 6, 7, all the way through 20. Well, that if I perform it, if I solve it the way I did in the example B, I will have to find the probability at 4, at 5, at 6, and all until probability of x is 20. So that might be easier to take the complement. What are the number that were not included? Then it could be at 0, 1, 2, and 3. That makes it much easier. I only have 4 probability to calculate, and that will give my 0.5886. Number of trial times the probability of success. And the variance of this random variable x will be given by n times pi into 1 minus pi. Of course, if we are interested in the standard deviation, it will be the square root of this variance. In our example, what is the expected number of withdrawals? So the expected number of withdrawal is n times pi, which is 20 times 0.2, which is 4. We expect 4 students out of 20 to withdraw from the program. What is the variance of the number of withdrawal? It is n times pi, 1 minus pi. 20 times 0.2 times 1 minus 0.2, which is 3.2. If I'm interested in the standard deviation, it will be the square root of 3.2. Excel offers the possibility of calculating binomial probabilities. The formula is very easy. As all other formulas in Excel, it starts with the equal sign. Binomial, B-I-N-O-M dot dist for distribution. We follow the step. X is the number of success, n the number of trial, pi the probability of success. At this point, we have to decide whether we want the probability at 1 point or if we want the cumulative. At 1 point, we use false. At cumulative, we will use true. And Excel will do the work for us. There are obviously some binomial tables that exist, but they are not for all values of n and all possible values of pi, the probability of success. This is why the Excel calculator is very useful. In our example, we can find all the probabilities that we were looking for using the binomial formula. The first one, I look at x equal 4, then I'll use false. X less than or equal to 2, I would use true. Let us go in Excel and see how we can simply apply those formulas. Here is my spreadsheet in Excel. I am looking at the probability that x is equal to 4. That was part A of our example. equal, like all other formula, and I start writing, and very quickly I will identify the formula that I need. I want it at 4 success. We have 20 trials. The probability of success is 0.2. And at this point, I am prompted with these options. Do I want the cumulative or the probability at 1 point? In this case, I want it at 1 point. And that gives me the probability of x equals 4. In our other example, I was interested in the cumulative. I wanted the probability at 0, 1, and 2. So this is x less than or equal to 2. I will use the same approach, binomial, and it is at my binomial distribution. Here I'm looking at the 2 success. There are 20 trials, 0.2 the probability of success, and in this case I'm looking at the cumulative. And here is my probability. That can be applied for all values of pi and all sample size n. Excel also offers me the opportunity to calculate combinations. In my example, I had 20 students and I wanted to choose 4. So in this case, I will go the same way, combine. So it is the first option. How many I have to choose from? 20. I wanted to select 4. And we remember this is the number we had calculated using the cancellation of number on the numerator and denominator. I hope you have enjoyed the binomial distribution. Binomial distribution is simply a tool that will be used later in advanced data mining. Have a good day.